So hello guys, again continuing with our sliding window approach here. Last time we have discussed about the brute force approach, like how we should proceed with the brute force. Now coming to sliding window approach, just a slight correction over here. Instead of I going to here, I will be going to this one. Right, so I will be going till length and then ARR and then it will be going from K, right? So it will go from K to len ARR. So before that, what we will do is we will first extract a new array here. So we are extracting a new array and we are simply extracting from 0 to K, right? So why we are doing this too? Because we need to take the what? We need to take this again here 213. So here in the new array, it will be nothing but 2, 1, and 3. Because from 0, if you count till 3, right? So 0 is the index, and we are counting till 3. But actually, it will not take till 3. It will take till 2. Because in Python, if you do a 0 colon k, it will go up to the last second. So 0, this 2 is of index 0, this 1 is of index 1, and this 3 is of index 2. So according to this, we are able to extract our first subarray into the new array, right? So which will be 6. Now, since we have removed or we have extracted the first subarray, what we need to do is we need to go from this one, from K, right? So we need to start from K. So what is K? So here K is given 3. If you have a proper look here, K is given as 3. So K 0, 1, 2, 3, right? So from 3 we will consider the so 3 becomes the last starting of the last sub array. So from that we will consider till the last of the array. But here, since this is a comma, it will go till last. It will not consider the last second element. It will consider the last element itself, right? So that is how it is going to work here. And so 0 till k minus 1, right? K minus 1 is 0, 1, 2. So that this has been extracted, and now this will go from here. But here this is just a small array that we have given, so this is not able to it's not able to enclose all the elements. But if we are considering a big array, something like this, 2, 1, 4, 3, and then 6, and then 1, then 5, now here it will be able to work properly. So suppose this is the array where I want to apply the sliding window approach. Now 0, 1, 2, 3, 4, 5, 6. So this is the array, and the first one is what? K is given as 3. So window size of 3 we have to take. So first thing first, we will consider this first 3 consecutive elements, and 2, 1 plus 4. So it will give me 7, right? So this is nothing but our first this instruction. We are extracting it. So ARR 0 is to K. That means from 0 it will consider till uh, suppose this is K, then K minus 1, right? Because in Python, if you write like this, it will go till the last second, not the last element. So that is done. Then here we are starting I, right? So I we are starting, and it will start from K. So K here is nothing but 3. So it will start from 3 and it will end at the last array of element 5, right? Because here comma means we will not count till last second, we will directly go till the last one. Now here what we will do is K, I will start from K, right? So I will start from K, and the value of k here is 3 here if you look properly. So I it will start from 3, and we will uh, do what? So we will try to add up. We will also have a current sum here which will be 0 at first, and then we will try to increment this one by one. So current sum, so I have this current sum, right? So current sum plus, then we have ARR of I, and then minus ARR of I minus K we have. So what we are doing here is current sum is here how much? 0. So 0 plus ARR of I is how much now? I is 3. So 3 is pointing to 3 element, right? So here we are adding 3 and we are subtracting the this one. So we are subtracting this one, right? So when we move the sub array to the next, to the right side, right? So when we move this by one element to the right, then we need to remove this. That's why we are subtracting here. And how will I know? I am doing ARR minus ARR I minus K. So I is how much here? 3. And K is how much here? 3. So ARR of it becomes 0, right? So ARR of 0 is how much? ARR of 0 is here 2. So that 2 I have to subtract it from here, right? So it becomes how much? Our current sum becomes 1. Fine. So like that you have to just substitute the value and then it will go on. So next, again we will loop this, right? So now we will try to check the max sum. And what is the max sum here? Max sum is nothing but trying to find the maximum out of current sum and the max sum. So max sum also we will keep it 0 at the top, and then we will try to calculate. So max here is, if you consider current sum is 1 and the max sum is 0, so obviously 1 is our max sum, right? So like that you have to move uh, one by one. One by one means one sub array into the another sub array, right? So you have to proceed to the right side, and we will go till the last one. So again, if you consider this, we will go this one. Fine. Like that, we will be moving and calculating the maximum sum. So here, what will be the time complexity? The time complexity here will be O of n, which is much better than the previous O n square or O n k, right? So that is here it is much more better. That is why we will always consider the sliding window approach here. So I hope you understood this. So let's try to code this out, right? And let's try to see. So let me write a code for this one. So first, let's write a code without what? Without sliding window. So we are writing basically the brute force approach here. So what I will do, I will write a function max, or I can say max sum, and then it will be receiving an array, and then it will be receiving the key value, right? Key is nothing but a window size. Then we will first try to declare a max sum of 0 value, and then for I it will go till where it will go till uh, the starting of the last sub array, which is len arr, and then minus k and then plus 1. Okay, and then we will also assign another current sum just to check current sum, and then again another loop within the outer loop. So it will go till k, right? So this will go till k, and then we need to find the sum here. So current sum equal to current sum, and then plus ARR of I plus j. So why we are writing I plus j here? It is because I, so whenever, so here what we are doing is whenever I'm incrementing the value of I, that means we have to move, right? So we have to move. So why I'm doing I plus j here? Why I'm doing I plus j is whenever I'm incrementing, right? So first it was 213. Now I want to consider 137. So to consider the next sub array, I'm writing I plus j, right? So that is the logic behind this. And then if you check again maximum sum, so we need to calculate the maximum sum equal to max, and then current sum. So we need to compare current sum with the max sum, and then it will return max sum, right? So this is basically the code that I need to use the brute force approach for my what for the k max sub array, right? So now if I try to print this, print max sum, and then I will just provide some array, some dummy array here, right? 2, and then let's give 5, and let's give 1, then okay, another 1, and then 7, and then I need to also mention the k size, window size. So let me give it 3. Okay, so here if you check, we have this elements in the array, and if you club it by 3 window size, if I club the first one, 1 plus 3 plus 2, so it is giving me 6, right? And then I will consider 3 plus 2 plus 5. So I think this will give me the highest, because the maximum will always depend on the uh, element with the highest value. So 3 plus 2 is 5, plus 5, 10, right? So now it should return me 10, right? So the maximum summation in the sub array should be 10, and it should be return me 10. So now if I run this, it should give me 10 as a returning value. Okay, line 11, max sum is not defined. Okay, we need to provide the correct function name, otherwise it will not run. So as you can see here in this array, the highest value is of 3 to 5 if we club 3 elements. So that's why the summation highest, it will give me 10. So that is the reason why it is uh, returning me back 10 value. So I hope you understood this for the brute force approach. Now moving on to our sliding window, right? So this is now for sliding window approach. Now here what I will do, I will write max sum same, then array, then k, and then to array the k value, since once it is provided, we can now start, right? So new array. So new array will be the first 3 combination of elements, right? So the first sub array sum. So I will just extract from 0 index till last second, right? So last second index where our k value will start. So k minus 1 till 0 till k minus 1, it will extract here. Then after extracting, what we will do, we will write the current sum here, and current sum is what? Current sum is current sum plus, and then ARR I. Okay, so what we are doing here is current sum. It is actually what current sum we have given how much? Okay, this current sum should be sum. Okay, this should be sum and then new array. So that means whatever the first three elements that we have extracted here, we just want to sum it up and we need to assign in the current sum. So after assigning to the current sum, now we will iterate from k from the starting of the last sub array and from k it will go till where it will go till the last of our array, right? And then we will try to calculate the current sum. So current sum equal to current sum plus arr I. Right? So arr I nothing here, it will be the starting of this one, right? So k here is nothing but 3. So this k3 it will start from here and it will go till 5. So that's why I'm writing here k till it will go to the last, and then current sum is already how much we are having. Already we are having 2 plus 1 plus 4, which is 7. So already we have this 7. So 7 plus what we are trying to do here, 7 plus ARR of I, right? So I is nothing but a k. So k value here will be 3, and then we will try to subtract what? So now we will try to subtract minus ARR I minus K. Okay, that's it. So here we are trying to do ARR minus ARR I minus K. Why we are doing I minus K? Because we want to remove the previous element here. So I is 3, then I is how much? 3 minus 3, so it becomes ARR of 0. So ARR of 0 is 2, right? So we will subtract 7 plus 3 minus 2. So it becomes how much? 1 and then 8, right? So our current sum will become 8 now. So that is how we are calculating this one. 1 plus 4 plus 3. So in sliding window, we need to discard the previous value when we are moving to the next subarray, and we are simply finding the sum of the next subarray here by using this logic. So now what we will do, we will again write max sum, and max sum here is max of what? Max of current sum, max of current sum and what? Max sum. So if we do this and if we return the max sum, right, then that's it. Our code is now complete. Now what we need to do is we need to provide some string over here. So I will provide max sum and then sorry, not string, we will need to provide an array here. So array I will give same thing like 1, then 3, then 2, then 5, then 1, then 1, then 7, and then the window size I will give it 3. So here again, if you look here, it should give me or return me 10, because the highest uh, consecutive value you can see here is 2 plus 3 plus 2 plus 5. So it will give me 10. And if you consider any other subarray, it will not exceed any what? Any 10. So if I consider this 7, so 7 plus 1 plus 1, so that is giving me 9. So if you compare 10 and 9, obviously 10 is the greater value, so it should return me 10 here also. So here you can see we have verified with the 10 here. And now if you see here, okay, we will take one more example here. So now what need to check is 8. So our value is now 8 here. Now we need to check 4 plus 3 plus 6, which should give me how much? 10, 13, right? So 13 should be the next sum. So what we will do, we will write the current sum plus ARR of I. So ARR of I will be now 4, right? So 4 value will be how much? 6. So ARR of I is 4 now, because K it was pointing to here and now it is pointing to 4 now because we have incremented. And then ARR of what? ARR of I minus K, if we do, then what it is giving me? I is how much? I is 4 and K is 3, right? So ARR of 4 minus 3 is ARR of 1, right? So 1 is how much? This one. The value is 1 also here. So 1, right? So here this is not plus, this will be minus here, right? Now if you check, then how much? 14, right? And minus 1, 30. So same thing we are also getting here. 4 plus 6, 10, then 13. So 4 plus 3 plus 6 is giving me 13. So that 13 we are able to calculate using this logic, which I have written it here, right? So this is very important, this line of code. From this only we are able to move from one subarray to another subarray. Okay. So I hope you understood this logic behind our sliding window approach. And okay, so I will see you in the next lecture. Take care.